Sarah, your example that you were going to say, you're saying if 3 to the power of x
equals 3, x would always be 1, or whatever number it is.
Okay, yep. So if you raise a number to a power and it remains as itself, then x equals 1. Sure. That's a rule that definitely applies to exponentials. Is there any way to express that logarithmically?
I'm not sure.
Okay. Is there any way that we can does anyone know any way to express this using a logarithm? The fact that 3 to the power of x.
You do it. You do log. Do the small 3 brackets 3. I don't know how to really say it, but I know what it is.
Yes. So we say log to the base 3 of 3. That's the one. Thank you, Lucy. That's exactly it. So yeah, and in your case, Sarah, that is going to be equal to 1. So okay, yeah, one consequence of logs, based on its definition, is that log to the base a of a is always going to equal 1, because it asks us to get from that base a to the a in the brackets, what do we raise the power? So we raise it to a power of 1, and that gives us a. Cool, thank you. Any other things about logarithms?
One of the laws you gave us at the end was log of x to the power of y.
Sure.
Is y times the log of x.
Indeed, yeah. Indeed. Indeed, that was definitely one of the laws. Definitely one of the laws. And you can use that to prove things such as log of 8 is equal to 3 log 2. So maybe it might take you staring at that just to see why that's actually true. So, Emery, any idea why the green writing is true based on the rule that Ben gave us?
So is it because
Not thinking.
it's because you can turn 8 into 2 to the power of 3.
Indeed.
And that's how it sort of goes.
Yeah, that's exactly it. Because 8 can be expressed as 2 to the power of 3, that power comes down in front. What was that?
Mine on speaker.
Sorry?
Yeah, sure. Are you sure?
Yeah, I can go for it.
Oh.
Thanks.
Okay, so any other laws?
Log x plus log y equals log xy.
Thank you. Excellent. So one of our laws log x plus log y equals log xy. It's technically an identity, but yeah. So we can say, for example, that log 8 is log 4 plus log 2.
Wait, sorry.
Yes.
Could it be any multiple? So could it still be 8 and 1?
Yeah, log 8 is the same thing as log 8 plus log 1.
Oh, okay.
Yeah, that's all right. And in fact, let's take that example just so that I can sort of put another rule of logs out there. If log 8, I'm going to rub this out, but if log 8 is equal to log 8, plus log 1, then what does that mean that log 1 is equal to?
0.
What would be 0? Yeah. The only way that you can have something is the same as that same something plus something else is that something else is 0. So one of those other consequences of logs, again by definition, is the log to the base a, where a is anything, of 1 is always going to be 0. So you raise something to the power of 0 to get it equal to 1. Cool, okay, and what's our third rule? So Felix kindly gave us our second rule. Now our third rule is actually kind of related to our second rule.
I think I know.
Yeah?
Is it log x minus log y equals log x divided by y?
Yeah, was that Ruby?
Yes.
Awesome, yeah. Log x minus log y equals log x over y, yes. So Felix gave us like the hard part, like coming up with it all together with the timesing law, and you've given us a division law, which works so basically the opposite. So these three laws are very, 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 very key. So whenever you're thinking of logarithms, you definitely want to have at least these three rules. So if you guys write these down, we're going to go into another activity, and so I'll just ask you a few questions just to double check. And then we will go on to some actual harder questions. Okay.
Sir?
Yes.
Do these laws have names? Because, like, you know, in physics, how you have like Newton's law and you have all the different ones.
They're just called log laws.
Because, like, well, for example, would a question be like, use this law, or would you have to figure out what law to use?
Yeah, you have to figure out what law to use. So it could be solving an equation. They'll just tell you solve this equation or show that this is equal to this, and you have to use the laws to show that. So, for example, like when we were doing, you can call these kind of log identities if you like, because they are identities technically. It's like when you do trig identities, you just ask to solve equations, and then it's up to you to figure out what equations and identities to use. It's the same with this. Does that answer your question?
Yeah, thank you.
Awesome. Okay, so here I'm going to say express the following in terms of log 2. Express the following in terms of log 2. So first one is this. One of the questions. Second question is this. By the way, when I write log without any base, it actually means log to the base 10. That's really something worth noting.
Sir, for the first one, does it say log 10 full? Or
Yeah,
log
log to
0
the,
full?
sorry, it says log to the base 10, yeah.
Okay, thank you.
Yes, log to the base 10. But we want to express everything in terms of log to the base 10 of 2. Sorry?
So sorry, you know, you just said if it has a log and it doesn't have a base, what does that mean again? Sorry, I missed it.
It means it's log to the base 10.
Would it always mean 10?
Yeah, when they write it about, unless they specifically mention what it is, you take it to be log. When it's without a log. Yeah. But I'll write it here just for ease. Okay, they are going to get increasingly harder. Well, kind of. Okay, so I'll give people just a few minutes to try and figure out what's going on. So we're expressing these in terms of log 2, and you are using your log laws. And when I say express it in terms of log 2, that's going to be the only log that you will have should be log to the base 2. So you can have like other numbers as well. So for example, an answer can be something like log of 2 plus 3. That is in terms of log 2.
What does the plus 3 mean?
That was just me giving an example of what something can look like when I ask you to express it in terms of log 2. So you can have, your answer is going to have some sort of log 2, but it can also have other numbers that's been multiplied or added or something like that.
Okay, so if you did log 2 plus an integer, what does the integer do to the answer, if that makes sense?
Okay. It doesn't, as far as we're concerned, it doesn't do anything. It's a bit like if you have x plus 3, the 3 won't do anything to the x. You just leave it as x plus 3.
Okay.
Yeah. That was a good question, though.
So, could you give us an example of when you use that, like log 2 plus 3? Like, what would that be the kind of answer?
Sorry, say that one more time?
Could you please give an example of like when you'd use like log 2 plus 3 or something like that as an answer?
Okay. So let's suppose you had log to the base 10 of 2000. We can say this is the same thing as log to the base 10 of 2 plus log to the base 10 of 1000, using that multiplication rule. Then we have log to the base 10 of 2 plus, and then log to the base 10 of 1000 is 3, because 10 to the power 3 gives you 1000. So that is an example of something that's been expressed in terms of log 2 only.
Oh, okay, thank you. Yeah, that makes sense.
Cool.
I'm a bit confused for the log 10.
Which one, sorry?
Of the log 10 thing. Do you have
So
any calculators?
it's what, the fact that it says log to the base 10?
Yeah.
What are you confused with?
What is it? What's the log 10?
As in, we're just, so the question is asking us, sorry. The question is asking us to express the following 5 expressions, if you like, in terms of log to the base 10 of 2. And the first question is log to the base 10 of 4. So using your log laws, the 10 doesn't really, in some ways you can kind of ignore the 10 when you're applying your log laws.
Okay.
Yeah, as long as the base remains the same, it doesn't change the log laws, if that makes sense. Does that make sense?
Yeah, thank you.
Cool. Okay. Can we go through some answers, or do people still want more time?
Can I have like 1 more minute,
Of course.
please? Manners.
Of course.
So I have a question.
Yeah.
You know, for the last one,
Yeah.
let's say like let's say you don't do the law, but instead like make them into different logs. Could you have more than 2, if that makes sense? Like, could you do like, let's say you find out you can get log 2 in a half, and then you can do like log plus log minus log. Would that work?
Log plus log minus log.
I don't know if that makes sense, but
Wait, say it one more time. I want to try and understand.
so like, let's say for example, you have like log 4, right?
Yeah.
So you could do like log 2 plus 2.
Yeah.
Let's say you have log 4 I don't know plus log 5.
Yeah.
You log 2 plus log 2 plus log 5.
I mean, it definitely equals that, yeah? Log 2 plus log 2 plus log 5.
That would work.
I mean, what you've said, this thing here, is true. It's a true statement.
Okay.
I feel like there's something more that you want to ask.
No. It's just to make sure that like I can do what I wanted to try to do.
Yeah, you can do, you can do what you want as long as it uses the laws.
Okay.
Yeah. hopefully you got what you wanted out of asking that question. I hope.
I did. Thank you, sir.
Okay, cool. What's the third one? Do you want me to give you a hint?
That would be great.
Cool. Think of the subtraction law.
Okay.
Izzy, have you got an answer for the first one?
I don't know if I've done like the right process, but I do have an answer.
Okay. What do you think your answer is?
So is it like, do I have to say log 10 in the?
Yeah, log to the base 10, or you could just say log.
Okay. Well, log to the base 10
Mm-hmm.
in brackets 2.
Yeah.
And then plus log, and then in brackets 2 again.
Yeah, that works. And in actual fact, that can be simplified to 2 log to the base 10 of 2.
If that was like an actual question, would I lose marks for not simplifying?
Possibly, yes. Possibly.
Okay.
It's like having the final answer is x plus x.
Yeah.
You might say 2x, but yeah. At this stage, I won't penalize too much just because I know we're just getting used to it. But yes, it's something that, typically if it was a real exam paper where you were like, at your best with this, then I expect you to put 2 log to the base 10 of 2. But the fact that you're able to break them up is the point of this exercise. And you've got that.
Thank you.
That's all right. Maria, the second one?
So it's log 10 2.
Mm-hmm.
That's log 10 10.
Yep.
Which then could also be log 10 5 and 2. Log 10 5 plus log 10.
Oh, okay.
So again to the.
But then, what does log to the base 10 of 5 become? That's like a horrible number, right? Let's suppose you didn't have a calculator for this. That would be quite a horrible number.
Oh.
But my question is, what is log to the base 10 of 10?
Honestly, I do want to listen.
10 to the base of 10?
Yeah. Log to the base 10 of 10.
Cool right now. You do that essay. Yeah, I know.
100? No.
It was actually quite hard. I just realized so does it post much material.
So you're thinking 10 to the power of what equals 10?
Oh, 1, sorry.
Yeah, that's right. So this one, expressed in terms of log 2, is equal to log 2 plus.
I see. Thank you.
Yeah, that's right.
No.
Did anyone do this first one? Because I know a lot of people had problems with this one.
Yeah, I did it.
Yeah? Was it Joe?
Yeah.
Go for it, Joe.
So because of the subtraction rule,
Yeah.
you can do log 100 minus log 2.
Yes. Yes. Log 100 minus log 2.
So
Which is.
And that log 100 can be simplified to just 2. So it'd be 2 minus log 2.
Yes. So what were you going to say?
could you say that you could do log 25 plus log 2?
If you have log, so I'm writing it down the bottom. If you have log 25 plus log 2, that is true. But then the problem is we haven't got an answer that's expressed in only log 2.
Oh, okay.
Yeah. So that third one was a bit harder to see because you have to go. I don't know, going backwards is a bit harder than going forwards. And assuming that 50 is 100 divided by 2 is the my trick there. What about the fourth one? Oh,
Could you explain
yeah.
The green box again? Because I'm still a little bit confused by it.
So using the log laws, I just gave an example. So Joe asked me an example, like to give an example of what we need to, of what we need to do, and to express log of 2000 in terms of log 2, I've used the multiplication law to say it's log 2 plus log 1000, because 2 times 1000 gives you 2000.
Yeah.
And then log to the base 10 of 1000 is just 3, because 10 to the power 3 is equal to 1000.
Oh, okay. Yeah, okay.
Yeah.
Yeah, no, thank you.
That's all right. What about the fourth one?
So,
log, yeah.
where did log 10 go? Why is it just log now?
When I don't write any base, it's the same thing.
Oh.
Yes. I mean, I can write it if you want me to, if it makes you, if it like is better to look at.
Wait, so I'm so confused why it's not needed, but it's written.
It's like when you say x, you always mean x to the power of 1, but you don't need to write the 1. With logs, for some reason, just log of whatever, just it's assumed to be log to the base 10.
Okay.
It's just one of those conventions. Yeah.
Yeah, thanks.
Yeah, that's right.
Wait, so does that mean it will always be to the base of 10 then?
Yeah, unless they specify something else, yeah, you take it to be log to the base 10.
Okay.
Cool, okay. Log of the square root of 2. Jackson, did you manage to do that one?
I didn't actually, well, I looked at it and I didn't get it at all. I thought it was something to do with the minus rule. But, so I did like, I did log 1 minus log 2, but then I just thought that didn't make sense.
For which one, sorry?
I did log 1 minus log 2.
But for which one? The fourth one or the fifth one?
For the fourth one, yeah.
Ah, okay.
But then, because I thought it's like how root x is half x.
Yeah. So how could I rewrite this one? How could I rewrite the square root of 2? Instead of writing square root 2, what could I write?
Right. I'm not sure, to be honest.
Yeah.
Would it be a half, or is it just?
Yeah. 2 to the power of a half. And then what does that become?
Could you do half log 2?
Yeah, indeed. So that expressed in terms of log 2 is a half log 2. So what about the last one?
So can I try the last one?
Of course.
Okay. Well, I used the rule of the powers for both of the logs.
Yep. Mm-hmm.
So log of a half becomes log 2 to the power of -1.
Yeah.
So then that's -1 log of 2.
Yep.
And then for the other one, it's minus log 2 to the power of 1/3.
Mm-hmm.
So then that becomes minus 1/3 log 2. So then you combine those to get -4/3 log 2.
Yeah. That's exactly it. That is exactly it. Thank you. That is it. That's how we do that question. Does that make sense to people?
Yeah.
Yeah.
Yeah. Cool. All right.
Can you keep it up for just a second?
Oh, yep. In this lesson as well, I'll introduce other types of conventional logs. So when you see log on its own, it means log to the base 10. And there's another special type of log called the natural log. And that means log to the base e. E is the special, one of the special numbers in maths, which has a very, very unique function.
Thank you, sir.
That's all right. Cool. So we've already established that log of, say, I don't know, a means log to the base 10 of a. But there are other types of functions, and there's a special one which we call ln. So ln of a means log to the base e of a, where e is approximately equal to, it's like 2.718 something. Yeah. Sorry. Yeah. So these are just some other things to be wary of. And this E is actually so special because with if you were to graph this particular value, so if you were to draw the graph of e to the power of x, and we're going to look at this more so next year, possibly later on in this academic year as well. If you were to graph e to the x, if you draw its gradient function, it's exactly the same as its original function as well. That's the special property that this e value has. And it's called the exponential function when it's put as e to the x.
So e is always that?
Yes.
Okay.
E is always, it's just like pi is always 3.141, which goes on forever.
Yeah.
E is this is only to 5 decimal places though. E is another one of those numbers that goes on forever without a repeating pattern, so it's irrational like pi.
So could you please repeat what you said about the gradient?
Yeah, so do you remember when you guys, I think I saw a homework task that Miss Mansell sent you guys on sketching the gradient function? When you guys sketch the gradient function of any of functions, usually the gradient function appears different to the normal function because you're looking at what its gradient is. With this one, the function of e to the x has the exact same gradient function as its original function. So e to the x graphed looks exactly the same. In fact, I shouldn't even put looks, I should put is. Is exactly the same function as its gradient function. Again, we'll look more into this a bit later. But right now, if you just see that, it's still a log. It doesn't change anything when you see ln. It's still a logarithm.
Thank you.
You're welcome. So these are just some observations to make. Okay. Moving on. So we're going to say express in terms of log A, log B, and log C. And then create some questions. So similar to what we're doing with the two, but except now it's with A, B, and C. Okay, so 6 questions there. Okay. Wait, first of all, how are we doing with the questions? Do we need any more time, or do people want to start going through answers?
I'm on.
Just a tiny bit more time, if that's
Sure.
We could start going through the first one.
Well, I'll wait till if people are still trying it, I don't know which questions people have tried. They might be doing it in a different order. So for those that wanted that extra time, was that extra time that I gave sufficient?
Yeah, thank you.
Cool. So Larry, you want to kickstart us with the first one?
Yeah. It'll just be log A plus log B plus log C.
Yep. Yeah. Join in. Sorry about that, guys. Yeah, that's it. That's it, Larry. And the second one. Nina.
Was that me now?
Yes.
I got 2 log A plus 3 log B plus 100 log C.
Yep. That's absolutely it. Absolutely. And the third one? Let's see.
I don't know if I'm right, but
Go on.
I probably am wrong. But log A plus log B minus bracket log C.
Yeah. When you said bracket, what did you mean?
Like I don't know. It just makes it easier in my head.
Okay.
Log
Like
C.
this.
Yeah.
Yeah, I mean, you could do that, and I understand why. Because when you take away things, especially when you're taking away more than one thing that's been added together, the brackets do become important because people forget to apply the negative to everything. Yeah, so the brackets that I put in red are not necessary in case anybody's thinking, why do you put the brackets? It's not needed.
So, could you put the brackets, bracket log A plus log B, and then close brackets minus log C?
Yeah, you could do that. You can do that. It means the same thing. Definitely. Scarlett, did you help us with number 4?
I got 2 log A plus 3 log B minus 4 log C.
Yes. Thank you. Oh gosh. Indeed. And the 5th one, Felix.
So that's the one I got up to. I can't go through it. I can try now.
Yeah, that's fine.
So you flip those into be log a to the power of a half times b to the power of 1/3 divided by c to the power of a quarter. Then you flip them, but I'm not very sure on how I flip them. So would it be 2a minus 1? Or
you don't need to do any flipping. Flips are usually with negative indices.
Okay.
So you've done the hard work actually. So at this stage, you can now.
So would it be a half log a?
Yep.
Okay, half log a plus a 1/3 log b by a 4th quarter log c.
Yep.
Minus 4 log 3.
Yep. Oh, thank you. Nice. Nicely done. Max, the last one?
Well, for that, I did 1/2 log and then in like one big brackets. I did then like log A plus log B minus 1/2 log C, like all inside the bracket.
What? As in like this?
Yeah.
Okay. Very, 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 very careful with this one. So when you do the half, because all of that's been raised to the power of half, that just becomes a half log of this. And then when you're doing your brackets, what you really want to do is this. It's just a half of. You don't have 2 logs. Does that make sense, Max?
Yeah, that makes sense.
Yeah. So, yeah, what you would say there is log A plus log B minus a half log C. And I like the use of the brackets in this case because yes, that half applies to everything. So that's a half of log A plus a half of log B minus a quarter of log C. Are there any questions about that? That page looks very satisfying. You guys have done a good job. No questions? Okay, you guys are good.
Does the quarter come from multiplying? Wait,
yeah, go on.
Does the quarter come from multiplying the half?
Yes, the half on the outside multiplied by the half on the inside. That's it.
Okay.
Yes. So how are we doing with that? Is that okay?
Yeah, I actually understand it.
That's good. That's a good position to be in. It's a good way to feel. That is good. Right. I'm going to use this sheet as my guide. So this is the worksheet that we were working on. Well, that I gave you guys. And you'll see here if you guys get a chance to practice, when you guys get a chance to practice, should I say. Question 3, the questions are very similar to ones that we've just been doing. Here, these kinds of questions are actually really good because this is where a lot of students get stuck. When they get to logs like this, going back to exponential form for some reason can trip people up immensely. So I'm actually going to take this and put this on PowerPoint. We'll go through just unlogging functions. So we're writing these in exponential form, and hopefully soon we'll see how useful this can be. So would anyone like to give us any, this is just going back to the definition again, just to make sure that people can go the other way. So, yeah, would you like to give me any one that you like? That's on the board there.
So the first one.
Okay. Whichever one you want.
Log 3 of 81 equals 4. Is that an equation, or is it?
So you'll rewrite, can you rewrite that? Rewrite an equality without using a logarithm.
Okay. So would it be 3 to the power of 4 equals 81?
Perfect. Yeah, that's it. Thank you. That's it. So hopefully people understand what we're trying to do here. We're trying to rewrite these expressions without the logs, but instead in exponential form. So Lucy, how would I write the second one? Is Lucy around? Okay.
7 to the
Georgie.
power of 1. Oh, sorry.
My bad. No, sorry, go on.
7 to the power of 1 is 7.
Yes. 7 to the power of 1 is 7. So if we can have a go at writing some of those ones. And of course, I'll take you to some questions where this is actually going to be useful. Okay, hopefully that was okay for people. Ruby, the third one. Is Ruby not there? Okay. Nadia, third one.
I got a half to the power of 3 equals 1/8.
Half to the power of 3 equals an 8. Can I ask if you pick the next person as well? Because right now I can't see the chat. And I can't think of names off the top of my head.
What, sorry?
Could you pick the next person to answer the next question?
Oh, Mina.
Awesome.
I got 3 to the power of 0 equals 1.
Yep. And could you pick the next person, Nina?
Sarah.
4 to the power of -3 equals 1/64.
Yep.
Wait, do I have to pick someone?
Yes, please.
Oh god. Oh wait, I don't know who went. Emery.
Would that be 6 to the power of -2 is 1/36?
Indeed. And could you pick the next one?
I literally have like no clue. Ben?
There we go.
Which one's? Oh, number 7.
Yes.
X to the power of Z equals Y.
And could Ben please pick the next person?
Has Scarlett gone yet?
You can ask her.
Scarlett?
M to the power of half equals n.
Awesome. Yes. Cool. So now we're going to try and put it together with some actual questions. And these will be the next questions that I will write. Can you solve these equations? I want to see what kind of progress people can make. So, one of the questions is this. First question. This could work. Third question. Just to use our newfound and just to remind you guys, and then of something equals log to the base e of something. Just to get used to that notation. And with the last answer, if you could express your answer in terms of E, if that would be needed, then that would be great.
Sir.
Yeah.
Someone asked a question in the chat.
Someone asked. Oh, thank you for letting me know. Yeah. Oh, thanks. I have to see who that was. If only one of them is to the base of 3, do the rules still apply? Oh, did I miss something? If only one of them, yeah, it is true that if only one of them is to the base of 3, then the rules. Oh my gosh, where's the question I wrote? Oh, sorry, yeah, I missed that. Thanks for spotting that. I should have written log to the base 3. Otherwise, that question would be, yeah. And to answer your question, no, the rule wouldn't apply if you need the same base. That would have become a very complex problem if that was what I had intended. Still doable, but just more complex. So, I think if we explain the first one, just to check that people are on the right lines, and then I'll give people time to answer the other ones. I just want to check that people have some idea. So, part A. Would anyone like to tell me how they went about it, or how they started doing it, or what the ideas were?
Can I?
Yeah, of course.
So I just wrote out the question first, which you don't have to do.
Uh-huh.
And then I kind of did what I do when we do like what's it called, factorizing. So
Yeah.
I just wrote 12, and I just did like a tree of like what you can multiply to make 12, since I know that it's an addition. And so I got 6, 2, 12, 1, and 4, 3. And then I had to think about I had to look at the thing. So x, there's one saying x minus 1, so then 4, 3 would work, because if it would be 4, 4, but then because there's a minus 1, it'd be 4, 3. So I put x equals 4.
Oh, wow. Okay.
So could you write it how you'd work that out?
I like how you did that, Sarah. That's one way you can do it. What's that?
Is that not how you meant to do it?
Okay, I wouldn't say that there's a way you're meant to do it because that implies that one way is like superior to another, which is definitely not true. It's just not how I thought you would do it.
Oh, okay.
That's fine. That's, by the way, when I say that it's not how I thought you would have done it, that's not a bad thing. It just means that I wasn't thinking about that. That's all.
Oh, okay.
And yeah, that works. That can work. So what I was thinking was if we use our log laws, but what you did as well was you did also use your log laws. We can combine the first two to become log to the base 3 of x squared minus x. So if I multiply x by x minus 1, I get x squared minus x. And that equals log to the base 3 of 12. So now I've got log to the base 3 of something equals log to the base 3 of something else. So those somethings must be the same.
Sir?
Yes.
In B, does it equal 2 or Z?
That is a 2. That's just not, yeah. That is a 2. Oh, sorry. Oh, dear. Sorry, that is a 2.
It's fine.
Yeah, one thing I will always do, by the way, is when I'm writing, my Z's will always look like this, with a line, to differentiate between the two. That's one thing I will always do, so yeah, I apologize. Oh gosh, I thought I got you angry there. So x squared minus x is equal to 12. And then this is a quadratic equation, so I've got x squared minus x minus 12 equals 0. And the factorization would be x minus 4, x plus 3 equals 0, which means x equals 4 or x equals minus 3. But wait, what is going on here? Can both of those answers be? Can I have both of those answers?
No, because on one of them you have x minus 1.
Say that again?
Is it well, you can't, because because minus 3 times minus 4 is minus 12, not positive 12.
Is it? Minus 4 times
No,
minus
wait,
3?
sorry. Wait. Now I'm just, I don't know.
Okay.
Sir?
Yeah.
Would it be because if you inputted 3 where x would be, it would become x times, it would become 3 times 3 minus 1 would be 2, so it would become 3 times 2, and 3 times 2 doesn't equal 12, so it would have to become 4 times 3.
But that doesn't say 3 though, it says minus 3.
Oh.
When you do log 3 of minus 3 in a calculator, it says math error. So
Yeah.
is it because it's a negative number?
Yeah, and also, let's think about this in terms of our exponentials. Because if I put in log to the base 3 of minus 3, that's telling me, let's just say it equals question mark, that means that 3 to the power of something is equal to minus 3. But since when have we ever taken an exponential and made it negative? How does that work? How does that work? Because if we do 3 to the power of 1, that's equal to 3. 3 squared equals 9, and so on. If I go into negatives, 3 to the minus 1, that equals a third. 3 to the minus 100 is 1 over 3 to the power of 100, so it's still positive. 3 to the power of 0 is equal to 1. So with exponentials, you will never actually get a negative if you're raising a positive number to some power. It will never happen. So one actual thing is that when you take the logarithm of something, so log of, I don't know, x equals something, x has to be strictly greater than 0. Has to be. It has to be. And that is something that is very, very important to recognize. So, because of that, my x cannot be minus 3. It's just x equals 4. Hopefully that makes sense to people. But the take-home message here is when you put something into a log function, the value has to be greater than 0. Given that we're dealing with real numbers, you have to go negative. No, oh gosh, no. You have to go positive. Does that make sense to people?
Yeah.
Cool. Any takers for the second one then?
I've done most of it,
okay,
but I haven't done all of it. So I started with log base 3 of x squared minus x equals 2.
Hold on. It says minus though. Can you do what you just did?
Oh, okay. That might make it a lot easier.
Yes.
So log base 3 of x over x minus 1, which is equals 2. And then log 3 of...
Do you want me to give you a hint here?
Could you just do 3 squared equals x over x minus 1?
Maybe you don't need that hint. Yep.
And then 9x minus 9 equals x. And 8x equals 9. So x equals 9/8. Okay, that's the answer then.
That's it. Thank you, Ben.
You're welcome.
So,
sir.
Yes.
Why did you go from log 3 to 3 squared? I might have missed that.
So do you remember in the previous exercise, Felix, where we did this?
Okay.
That's what that is.
All right. Cheers. Thank you.
That's all right. It's usually something that people miss when solving equations because it's one of those little things and it's like, oh, but that's why I put these. But you probably were thinking, well, these are quite easy, but when you're only focusing on that, it is. But when it comes up as part of a bigger question, it can be easily missed. Okay, anyone for the third one? Would anyone like to walk us through it or suggest some ideas? Yay, nay?
Sir, would
Yeah.
you start with the conversion of the ln thing?
Yes. Yes. Absolutely.
So
tell me.
so 3 log e x
Okay, yep. 3 log to the base e of x.
minus log e 2x equals 5.
Sure, yeah.
And then would you just like times the e
Times? Should I say, what's your reasoning?
Sorry?
What's your reasons for doing that?
Not timesing. I meant like timesing out, like getting. Oh, because log e is a function in itself, right?
Yeah.
It's not just like
Yeah.
log times e. Okay. Yeah, I got up for that. Sorry, sir.
Okay, that's fine. That helps. So one thing that we want to do is combine those logarithms. But what do we need to do before we can combine logarithms?
Could you do something with the 3, but I don't know.
Yes, it is do something with the 3.
Could you make it x to the power 3?
Yes, indeed. You could.
Oh.
Like that, and you make it x to the power 3, then whoop, makes it much easier to combine.
I was thinking this probably won't work, but I thought. Oh wait, never mind. No, it won't work.
Okay.
I was thinking of factorizing, but that won't work, would it?
Yeah, you can't factorize at this stage because there's no common terms per se. Because remember, log e is a function; it's not a number or a term that's being multiplied. Okay, so what can we do at this stage then, Sarah? If we were to combine logs?
Well, due to the laws,
Yeah.
it would be x cubed over 2x.
Yeah, log to the base e of that, right?
Yeah, sorry. Equals 5.
Uh-huh.
And e to the power of 5 is x cubed over 2x.
Mm-hmm.
So then, would you multiply 2x?
Well, rather than multiply by 2x, you can actually simplify that fraction.
Oh yeah, sorry. So x squared over 2.
Yeah.
So then 2e to the power of 5 equals x squared. Oh, and then square root of 2e to the power of 5 equals x.
Mm-hmm.
So x equals.
That, it's just that. Leave it at that. Leave it in terms of e.
Oh, okay.
You're good. Question, because it's x squared, could I have the negative square root as well? Am I allowed to have the negative square root?
Yes.
Okay, what do people think?
Wait, no. Wait,
Why?
So
x could be
negative. Like you can have a negative squared will make it positive, but you can't have a negative square root.
So you can't have the square root of a negative number in our case with the numbers that we're dealing with, but can I have that? Because that should also be an answer, no?
Yes.
Okay, guys, what else? What do other people think? Can I have that?
No, because when you put x into a logarithm, then it needs to be positive.
Yeah. So this negative square root of 2e to the 5 is unfortunately negative, and the logs cannot take negative values. So always be careful. So it's just that as an answer. How do people feel about that?
I need practice for that.
Okay. Yeah, it can be a bit tricky because we'll mix together a lot of things, especially because you guys are learning so much in one go as well. And we will have some time next week as well to do some practice on Monday as well. We will. All right. Okay. Let's solve.
Sir.
Yes.
Would it be okay if I leave at 4 today because I have to catch a train? Is that okay?
Yes, no problem.
Thank you so much.
No problem. Okay. So we're going to solve other types of equations, and those kinds of equations will be ones like this. Right. With this, the kind of technique that we want to adopt is a bit different to what we've done in the past. So it would be nice to say log to the base 2 of x plus 1 equals, but the problem is you're going to end up having, so what we could try is this. We could say log to the base 2 of 3 to the power of x equals x plus 1. But that's horrible because you've got a log, and inside the log you've got an x, and then it equals some answer of x. So that's not going to be nice. But what we can do is we can take logarithms of both sides. So we can say log of 2 to the power of x plus 1 equals log of 3 to the power of x. What does that help us do? Because it looks like I've just made it more complicated. Why is that useful? What could we try from here?
Because you don't have different. Okay, no, sorry.
Okay. I feel like someone else was going to say something as well.
Yeah, I was gonna say, because there's no base, could you do log 2x, 2 to the power of x plus 1 minus log to the power of 3, you know what I mean, minus thing equals 0, and then because they're the same base, which would be 10 because there's no base written, then it would be 2 to the power of x plus 1 over 3 to the power of x equals 0.
That is correct maths. That is definitely correct maths. So let me just write out what Sarah said. So your idea was to do this.
Makes it more confusing.
And then do this. But it works, but it doesn't help us advance, unfortunately. Like the maths is correct, but we actually end up going back to the same starting point eventually. I encourage everybody to try and see why as a little challenge. But Ben, I heard your sound come on. I feel like you were going to say something.
Could you make it x plus 1 log of 2 equals x log of 3?
Yes, you can. Yes, we can. So by using the power law, x plus 1 lots of log 2 equals x log 3. And now this is actually just a basic linear equation. Though the numbers look a bit scary, it's a basic linear equation. Because now if we expand the left-hand side, this becomes x log 2 plus 1 log 2. I'm going to write 1 log 2 just because it makes it a bit easier maybe. Equals x log 3. And because I'm trying to solve for x, I want to get everything with x on one side and everything without an x on the other side. So I'm going to take it to the right-hand side. It just looks easy. 1 log 2 equals x log 3 minus x log 2. At this stage, I can now factorize. I'm going to write this as log. I can factorize my x. And then that tells me that x is going to equal log 2 divided by this entire quantity. So such equations can be solved with this technique of taking logarithms of both sides. I'm going to leave that on the board. And with that, I'm going to ask another question. So another question. Can you guys solve this one? So can you guys solve that? So I've left the other one there on the board so that you guys can see the working and use it as a guide. If people have questions, then please ask. Have people made progress with that question?
I think I have an answer, sir.
Okay. Is anyone opposed to going over some answers? No? Okay. 7 to the power of 2x plus 1 equals 6 to the power of x plus 1. 7 to the power of 2x plus 1 equals 6 to the power of x plus 1. Okay, that's okay. All right. So how did you go about doing it, Max?
So I started off and I did 2x plus 1 and then log 7, like in brackets.
Oh, okay, so let me just, I think you might have skipped a little bit, but that's okay. Let me just quickly write the first taking logs of both sides. Yep, so you said
so 2x plus 1 and then log 7 is equal to x plus 1 log 6. And then I expanded that to get 2x log 7 plus log 7 is equal to x log 6 plus log 6. And then I made it so that the x's are all on one side. So I got log 7 minus log 6.
Yeah.
So I just minused the log 6 from that side. And then I got equals x log 6 minus 2x log 7. And then I factorized like the right hand side. So x was like on the outside of a bracket. And then inside the bracket was log 6 minus 2 log 7. And then I basically just divided the right hand side and the left by the brackets, so that it meant that x was equal to log 7 minus log 6 over log 6 minus 2 log 7. I think.
That is absolutely correct. Yeah, nailed it. Smashed it. Very nicely done. Very nicely done. Are there any questions about that? Okay. The next question, I might have to type this one out just because it's probably easier to type. I even spell. I really hope that's how you spell it. Right. Can we see the question?
Yeah.
Awesome. So here, I invest £1,000 into a stock. My money increases at a rate of 1% per month. After how many months will my investment have quadrupled? First of all, actually, before we even answer this question, if you actually were able to achieve that, would anybody like to guess how many months they think it would take if it increases at 1% per month? Let me just put compound interest, just to be clear. Would anyone like to hazard a guess as to how long it will take before we actually work it out? You don't have to do any working out. I just want to know what you guys might think, given that you're going at 1%, which is low. Any guesses from anyone? So, what do you think? I've got Sarah in the room with me. So, here's a question on the board. I invest £1,000 into a stock. My money increases at a rate of 1% per month. Compound interest. After how many months will my investment have quadrupled? Yeah, but without using months. Like if you just had to take an intuitive guess, how long do you think? Without using that? Yeah, just if you have to guess, how many months do you think it would take?
1%. What am I doing? I have quadrupled my investment. So £4,000.
To go from 1,000 to 4,000, how long do you think it would take?
Oh,
guess.
Put me on the spot, man.
Yeah.
I'm trying to work it out.
No, you're supposed to guess.
Oh, I'm not supposed to guess.
If you work it out, then it's not a guess.
1% not a lot.
1%'s not a lot.
400?
400 months. Okay.
Maybe more.
We've got a guess of 400 months.
Maybe more.
Maybe more. Anyone else want to guess?
We need to work out that power, isn't it?
Was that
power?
Yeah.
So there's no way to work out by guessing, yeah?
I just want to know what people think.
Probably more.
Well, it will probably be a bit less because it's 1% per month and it's going to increase. Right?
Oh gosh, I spelled that so wrong. Okay, so what do you think it might be, Lucy? If you had to guess.
I'm going to wait for the answer.
1%.
Sorry?
I'm going to work it out.
1% would be a pound. And if you add a pound every time.
Wait, guys, I genuinely want you guys to guess.
Don't work it out.
Yeah, guess first.
250.
What's that?
250.
250 months. Okay.
250 months.
Ben, what
I'd
were you
say
thinking?
300.
Oh, you should say 300.
I was gonna say like 10.
I'll say 350.
350.
5.
Ben?
360.
360 months. Oh gosh, that's a lot of months. What is that, 30 years? Is it? 12 months in 1 year. 12 times 30. Yeah.
No, why not?
3 years.
It's almost 3 years.
Oh wait, no, 30 years. Wait, 30 years.
30 years. Oh, okay. You said 360 months. Yeah. Okay. So now, question is, if we were to try and work this out, how can we use? What can we do? Or can we set up some sort of equation?
So I think it'll be even less.
You think it'll be even less?
Yeah, I was going to say, I reckon it's probably going to be like 50.
50, okay. 50.
Or maybe like 75, somewhere around that range.
50, maybe 25.
Okay. I said 75, sorry. I don't think it'll be 25. I think.
75, okay.
No, I think it's going to be like 10 or 12.
10 or 12. 10 or 12. Oh, wow.
1% of 1,000 is 10 quid, so that goes up quite high.
Okay. Okay.
Put 150 as well.
150, okay.
Oh, man, I want to second guess now. I'm using the carpets, I'm not allowed. My guess was way off. You put me on the spot.
Yep, no, I did. And to be honest, I probably would have said something similar.
That's crazy.
So what do we so how can we actually set up an equation to work this problem out? Now we can actually do the maths and we're not going to guess.
So would it be 1,000 times 1.01?
Yeah.
Uh-huh.
And then you just kind of square that by any guess you have. Square the 1.01.
So raise it to some unknown power.
Yeah.
Like this?
Yeah.
Uh-huh. And what do you want that to equal?
More or the same as 4,000.
Yeah, 4,000. Okay, so you want to say more than or equal. Okay, you want to set up an inequality. That's one way you could do it. We want it to equal 4,000. That should be good. That's good, Larry. How do we do
1.01 is equal to 1.01.
Did someone say something, by the way?
Yeah, but no, never mind.
Are you sure?
I was going to say something, but I don't think it would work.
Could you divide both sides by 1,000?
Indeed.
That's what I was going to do, but I didn't know.
I didn't know what you say. Oh, no.
1.01 to the power of x equals 4, and then it would be log 1.014.
Oh, so that is base. Oh, it's awesome.
So then x, drum roll.
Yeah, drum roll. What does it equal? Who was the closest guess?
It's a kid.
Okay, you ready?
Yeah.
139.
What?
So I guessed 150, but.
Ooh, 139.
So why is that different to this?
Because
they know the difference.
Well, it was 139.3, so maybe 140.
It's 139.3. So yeah, it wouldn't be it will be sometime after in year 140. It will have more than quadrupled. Cool. So surprising stuff, but some real life stuff. If you guys are looking at investing in stuff, you can work out if you have an estimated return of investment, when you can expect to multiply your certain money by whatever amount. Cool. So we've pretty much solved all the different types of equations needed this time around. We're going to do a bit of practice just with some harder type of stuff and some more problematic type stuff on Monday. What I will do is set some questions. I'll write it on Google Classrooms, but just so that you guys are aware, I'll take some questions from this worksheet, which I have uploaded on Google Classrooms, but I'll upload it again as a mini assignment. And we'll be focusing on some of these questions here. Are there any questions before we finish?
It's not a question, but I did really enjoy this lesson today.
Ah, I'm glad. Thank you. Thank you for letting me know. No, it's always good. Yeah, of course. It's good. It's good for me to, like, it's good to hear. Because I know it's online and stuff, and I'm wondering, oh, how much can we really do? But
like I said, I'm still really taking this for granted because I'm not prepared for when it gets hard.
I mean, to be fair, it has started getting more challenging already. You know, you guys, you probably haven't realized, but you guys have all grown. Like, you guys aren't GCSE students anymore. You guys are officially A-level. You know, when we started in September, okay, you guys were like big kids in terms of GCSE. You guys are like GCSE students entering this territory, but now you guys have evolved into A-level students, and I'm seeing that change in you guys. So
it's a lot harder.
It is a lot harder, but you guys are also managing. You know, so well done.
So can you quickly go back to the question we did before the compound interest one?
Yes. So which one? This one?
Yeah.
Yeah.
Did you say that x is equal to -1?
X is equal to -1, you say?
Oh wait, never mind. I didn't.
I know why you would say
but
that.
still, could you simplify it somehow?
You probably could. Yeah. Okay. Let's try and simplify it.
Couldn't you cancel out log 6, or is that not possible?
You can't cancel it as it is currently, but what you can do is say log of 7/6 over log of 6/7². That's not the best you can do. Because remember, if you have log of something divided by log of something else, you can't cancel anything. That's probably.
If you said that -x was equal to log 6 minus log 7 over log 6 minus 2 log 7, could you then cancel out the log 6's? And then
if you were to say that -x equals log 6 minus log 7 over log 6 minus 2 log 7. In this case, unfortunately, you still can't cancel the log 6's because, again, the fractions, the expressions are separated by minuses.
Oh, yeah.
Yeah, but I'm glad you were thinking about that. But yeah, in this case, you can't really do much, annoyingly. If it were log 6 minus log 7 over log 6 minus log 7, then in that case, yes, you could say it's definitely equal to 1. But because there's a 2 log 7, can't do that, unfortunately. I mean, what you could do, actually, which is really weird, I just need to hold it. Okay, I need to hold that expression in my head. Log 6 minus log 7 over log 6 minus 2 log 7. Log 6 minus log 7 over log 6 minus 2 log 7. Log 6 minus log 7 over log 6 minus 2 log 7. What you could do is this. It's going to be very weird.
So, is it okay if me and Joe go?
Yes, it is.
Thank you so much. We'll see you on Monday.
Yes, see you on Monday. So I lost my train of thought. Okay. Yeah, take care to you both. So you could do that. So what I've done is I've taken away log 7 and added log 7. And then what I end up getting is log 6 minus 2 log 7 over log 6 minus 2 log 7 plus log 7 over log 6 minus 2 log 7. Doesn't really make it that much more simple, but this bit at least we can now simplify to 1 plus log 7 over log 6 minus 2 log 7. It's not really that much more simple, but it is a little bit.
Okay.
Yeah. So to be honest, in an exam, they probably would just ask you to round it to like 2 decimal places or 3 significant figures or whatever. But yeah, you can't really do much more than that. It looks like you could. It looks like one of those things where you should be able to do something, but not really. Yeah. But that was a good question, though. Yeah, so are there any other questions? Any other questions at all before we finish? Nope. Okay. Well, you guys have done really well. You guys have risen up to the challenge. So yeah, I will set some questions from here and we will reconvene on Monday. Take care, guys. Have a very good weekend.
Thanks, sir.
Thanks. Bye.
You're very welcome. Take care.
Thanks, sir.
Alright, in a bit.
See you. Ah, yes, you're welcome, Aurora. Cool. Felix, are you there? Did you want to ask me something or? Okay. Felix, you all good?